Has Saurabh shared you something in the WhatsApp group? No, we are going to play one game. That's why I asked him to print out. Right away, so he will share this one. The injection game we are going to play. We normally hear this term blockchain and all those things, but we don't know how exactly it works basically. We say that safe, transfer and all those things. But we don't have that much knowledge about exactly how it works. We are going to understand that the working of blockchain with the help of blockchain. Let me know once it is ready, Venkat, online, so that I can start. Yes, it is working. Okay. यहाँ से कुछ करना है. We can start? Okay. Good afternoon, everybody. Welcome back to the GIAN course on next-gen supply chains, harnessing IoT, digital twins, and AI-driven simulation. So this is the 9th day of our GIAN course. In today's session, we are going to talk about blockchain technology for supply chain traceability. Yesterday, we discussed the IoT. Internet of Things, what are the types of Internet things, how does that Internet of thing works basically, and then what are some applications of Internet of Things in different parts of the supply chain management that we discussed. On another very fascinating and excellent technology of Industry 4.0 or Industry 5.0, you could say, that is a blockchain technology. You might have heard this word blockchain technology, or this name of that technology, blockchain. We are going to talk about in depth. So starting from the history, when who coined this blockchain term, and who was the first body or the first person who used this blockchain technology, what are the features of this blockchain technology, and why nowadays everybody is talking about we should use this blockchain technology for various applications, in not only in supply chain, but there are many applications of this blockchain technology in different sectors, in different industries. So I hope you will enjoy this today's session. So let's start the session now. Session objectives. At the end of this session, you will be able to understand the basic of blockchain and distributed ledger system. What is blockchain? Why do we call it as blockchain? What is the distributed ledger system? And then we are also going to talk about the role of blockchain in supply chain transparency and traceability. And then we are going to see the concept and functionality of smart contract in supply chain finance, because Blockchain is also used for the smart contracts in supply chain management that we are going to discuss and evaluate the impact of blockchain on supply chain efficiency and risk management. How could we use this technology for improving the business operations? How could we manage the fraud, scams, or how could we deal with some unexpected events in your supply chain? That we are going to discuss. Our usual way of starting the session, just get to know about what do you know about this technology, and then we'll jump into our main content. Go to menti.com or you can scan the QR code. Did you know this menti.com earlier? Have you heard? Yeah, so there are many things you could do in this menti.com. I don't know whether you have got the full access here or not, but you can do so many polls, quizzes, many things you could do in this. This is really user friendly and very good tool. Okay, so let's move on to our first question. What comes to your mind when you hear blockchain? Blockchain, Bitcoin. I don't know whether you know Bitcoin, cryptocurrency. What do you hear? What comes to your mind when you hear blockchain? Decentralized network, transparency, Bitcoin, transparent payment. Yes. Base of cryptocurrency. Yeah. Sometimes people they think that blockchain is mainly used for the cryptocurrency, or cryptocurrency are based on the blockchain technology platform. But there are many applications in other area. It is not only in the finance area, but if you take any industry, there are many applications of this blockchain technology. So yeah, so these are some of the words you can say: data transparency, Bitcoin, cryptocurrency, decentralized network. But there are some additional characteristics of this blockchain as well. We are going to talk about those additional characteristics. What does basically this blockchain mean, and what are the different features? Which industry first made blockchain famous? Any idea? Healthcare, banking, finance, agriculture, or education? Any idea in which industry people have used this technology first? That's correct. Banking and finance initially, we use this blockchain technology to make the secure and transparent transaction payment. Which of these not a feature of blockchain? Transparency, centralized control, immutability, security. Transparency, centralized control, immutability, security. Good one. What do you think? Which one is correct? And then why we have got the 5 students? Immutability. Centralized control. It is a decentralized ledger. It's not the centralized one. Immutability, that is the important characteristics of your blockchain. Once you record the transaction, you cannot change the transaction. You cannot amend it. Unchangeable. That's why immutability is one of the important characteristics of that your blockchain. Which big company has implemented blockchain for tracking food supply chains? Any idea? In supply chain management, which company has used it initially? Amazon, Walmart, Netflix, Tesla? Walmart, okay. Which big company has implemented blockchain for tracking food supply chains? So let's see the answer. Walmart. Yeah, Walmart, they have used the blockchain for tracking the food supply chains from farm to the your customer level. So your pre-existing knowledge on this topic? No knowledge, little bit, you have done some courses, or want broader knowledge? A little bit, you heard little bit about this technology, you want more information, additional details about this one? Taken a basic course, good one. You might have taken on some online platform. There are some courses available on online platform to learn about the blockchain technology. Good one. So you have got a couple of students. Most of the students, they heard about this technology, they know little bit about it. So we are going to explore it. What is it exactly, and what are the applications of this technology? What do you want to learn? Any specific thing you want to explore today? Blockchain applications, how does it work? Because basics of blockchain, yeah, we are going to talk about all those basic stuff. Consensus in blockchain, yeah, that is another very interesting stuff in blockchain. Consensus, what are the rules? Implementation in supply chain, yeah, how to make blockchain, all about blockchain, its basics and its uses, application of BCAT in supply chain perspective. A basic understanding, yes. So yeah, basically we are going to start from the basic stuff. So what is blockchain? Why do you call it as a blockchain? And then we are going to talk about the advanced stuff as well. What are the key terms in blockchain? And we are going to play a very interesting game as well, blockchain game. With the help of that game, you will understand how exactly it works. Any questions? If you have, then you can post here. Otherwise, we'll move back to our deck. So what is blockchain? Any idea? Decentralized network. Okay. Why do you use blockchain? What is the need of blockchain? Better transparency. Transparency is one thing. What else? Security. Control. Control of what? Yeah, you are saying no one can control it. Okay. Yeah. One person cannot control the whole network. So all the peers, involved in that network, they are, authority, or they are responsible for managing that whole network. So that's the another important terminology in blockchain. So blockchain is a digital decentralized ledger. Do you know the ledger? Keeping the records of all your transactions. Then it is called digital. Why we call it as digital? Because we keep the digital record of your transactions. Okay. So if you keep the record paperwork of your transactions, how much invoice or how much orders you received, what is the supply available, shipment details. So that is a paperwork. Okay. So here blockchain is a digital. We keep the digital copies of your transactions. Digital copies of your transaction. Digital decentralized ledger that records transaction in data blocks. Okay, so there are blocks. Each block contains the information of your transaction. Information. When you say the transaction, it doesn't mean only the financial transaction. Transaction, summons I am a supplier and you are the manufacturer. So I deliver the 100 products to you. I made the shipment. you agree that okay 100 products are coming from one of the supplier, what time it started, all those details, what is the quality of that product. So whenever we do this kind of transaction in supply chain as well, when manufacturer is sending the products to distributors from retailers, from retailer to the customer. So those kind of transactions. Suppose if you want to do the payment, online payment, so that is also one kind of transaction. So when you see this transaction in data blocks, so don't think that financial transaction. You see transactions in supply chain perspective. So digital, it is clear, we keep the record in the digital form, that's why it is digital ledger, keeping the records. Decentralized. What is decentralized? Decentralized means, suppose take an example of a bank. Suppose Venkat wants to transfer some money to the Chinmay. How does it happen basically? Venkat goes to his bank, or Venkat send the request to the bank, his bank, that bank, whatever that bank, it checks the the recipient records, it checks the Venkat's bank details, name and all those things, and also checks the Chinmay's bank details, everything. Once it is matched, then they do the transaction. That's so who is responsible here managing that transaction? Your bank, government body, they are managing this transaction. Okay, so in blockchain basically decentralized ledger. Okay, thank you. So in blockchain we don't have that one centralized body which look after all the transaction. Okay, so here whoever is making that transaction, so all the parties involved in that network, they are responsible to approve that transaction. Okay, suppose there are suppliers, manufacturer, retailers, customers, everybody is involved in your supply chain, and when some new transaction is adding into your digital ledger, then it is not only the one person or the two people, supplier and manufacturer, they approve it. So that is again the consensus mechanism. So majority of the people, they need to approve that transaction, then only it gets added to your blockchain. Otherwise, if suppose majority means suppose 51%, okay, so if out of 100%, if 50% people approve that transaction, then only it gets updated. If you have got 40% approving that one, it doesn't work. That information will not get updated into your ledger. So that is your decentralized. So everybody decentralized at different nodes, they are approving this transaction. So it is not only the single body who is approving your transaction. So it is a chain of interconnected encrypted blocks. These blocks are encrypted. Okay, so you cannot basically change any information in those blocks, and again interconnected. Why we are saying interconnected? So your first block initially will come open. Okay, first block, it is we call it a Genesis block. So everybody is aware of that one block. When you make the another block means you are adding the additional transaction, second transaction or second details. Then this second block, it is made from some information taken from your first block. So all the blocks, they are interconnected. Okay, suppose you want to create the third, fourth block, it is related to the preceding block. So suppose if you don't have the information of the preceding block, you randomly make something, that blockchain will not work. So that's the interconnected. All the blocks are interconnected. They are encrypted blocks. So you cannot change there once you record those transactions. Blocks, what do you mean by blocks? Blocks are the containers of the data that define a piece of digital information consisting of transaction along with the timestamp and cryptographic function. So I'm saying blockchain. The first word is block. What does that block means? Block, it contains the digital information of whatever transaction you are doing. Suppose supplier is doing the shipment or manufacturer is doing the shipment to the distributor. So whatever who are the recipient, who are the sender, how much the products they are sending, what is the quality of that product, when they are doing the shipment, all that information you keep in a digital form in a block. So what normally that block consists of? the timestamp when that information is updated there, when you are sending those products, shipments. Then cryptographic function again to make sure that, so this transaction is safe. So that is another cryptographic function of the blocks. So that's your block. Then blockchain presents time-stamped and immutable blocks. What is immutable blocks? Unchangeable. Okay. Timestamp. So when you do any transaction on, and then when you try to record that transaction into block, timestamp will be there. The heading of the block, what is the information you want to say. Then the immutable blocks means once you record that transaction or that block is ready, after that you cannot come back and then you cannot change anything. Once it is recorded, done. Nobody can change that record after that one. That's why it's called unchangeable network. Sometimes if you got some your paperwork or traditional way, you go back, you make some changes. Suppose you are sending as a supplier, suppose I am sending the 100 products in traditional way. So many times what happens, I can go back, I can make some changes in that whatever the paper record. So those kind of frauds normally happen in the traditional your network. But here timestamp is there, all the recipient, who is the supplier, what you are saying, what is the quality of that product, everything will be there. So we cannot change those blocks that are not owned by any single entity. So in case of your normal traditional transactions, all those transactions are owned by your banks or the centralized body. They look after who is paying, who is getting the money, how much they are paying, all those things. But here, everybody involved in that network, they keep the record of that transaction that are not owned by a single entity, but rather managed by a group of nodes or computers. So who are involved in that blockchain, like group of nodes, the entity in your supply chain or computers, they have the a copy of each digital transaction, each blockchain, where each block is secured and linked using the cryptographic principles. Again, as I said, these are the cryptographic, the functions to secure that blocks, and they are secured and they are interconnected. Once the data is recorded, and after some time you cannot go back and you cannot make any changes. It is done. Okay. But again, consensus mechanism is there in order to approve that block, in order to approve that transaction. So the immutable, unchangeable nature of the block, decentralized nature of. So these are some of the characteristics of your blockchain. Unchangeable, then decentralized. In normal way, in normal transaction, we have got the centralized body, but here decentralized body are there. What are some of the benefits of decentralized nature, guys? Tell me. Have you seen that sometimes when you go for the online banking or when you do some railway booking, you see server is down. Server is down, so something happened. That's why you are not able to do that transaction there. Why is it happening? Because of the limited servers, I will able to manage the whole that the transactions or the happening in that bank or happening into the railway reservation booking. But instead of that, if you are the decentralized nature of your transaction, each that decentralized node, they manage their transaction locally. You don't need to rely heavily on that centralized network. Okay, so that is the benefit of your decentralized nature of blockchain. It has redefined trust, ownership, identity, and financial systems. So basically, suppose whoever is doing that transaction, if they are getting the exact information, all the information, what's happening in the supply chain, it means that the trust will be built in the in everybody's mind. Ownership, everybody is owner of that transaction. Suppose supplier and manufacturer is doing some corruption or they are doing some wrong things, other members, they have the authority to approve that transaction. Okay, if supplier and manufacturer, they are doing some corruption or they are doing some the not good practices while doing the business, so all the members who are involved in that, they have the power whether that transaction you want to approve or not. If you think that something is not right, you reject that transaction, and the decision normally taken based on the majority level. So there are various consensus algorithm as well there. Identity, trust, ownership, and identity. So that's another very interesting stuff of identity. It is safe. We don't know, who is doing anonymous, basically the information about the transaction. Financial system, by providing a secure, you cannot, face any problems. They are fast. Like here, as I said, if you go with the centralized one, sometimes your server is down, something happen. So that's not a fast process here. Fast, transparent. Why it is transparent? Everybody can see in that network what is happening, who is doing what information is going, how much product we are getting, when we will get those products. Transparent and pseudonymous solution. Again, this pseudonymous solutions means we don't know exactly all the members in the we know them, the pseudonames, but we don't know exactly their real identity. So each block is linked to its predecessor. Okay, so what I'm saying that, so first block, everybody is aware of that first block. Okay, because when you want to create the blockchain, first block is we call it a Genesis block. So everybody knows that block. But after that, then when you create the second block, so there is some mechanism available to link that second block with your previous block. Okay, so when you link that second block with the previous block, suppose you make 4-5 blocks, and after 4-5 blocks, if you want to make some changes there, so you cannot simply make that change without considering the previous block. If you want to make some changes, it is really difficult. Why? Because it is they are all interlinked, and if you try to make any changes in any of the in any of the block, if you try to change some information, whole blockchain will be collapsed. So each block is linked to its predecessors using a cryptographic pointer. The chain continues back to its first block. First block is the Genesis block. Everybody is aware of that block. So what are the key characteristics of blockchain? Decentralized. No single authority controls it. So in your traditional network or in traditional form, the banks, the governments, they control the your whole transactions. But here, no single authority controls it. Who controls it then? Everybody involved in that network, they controls that blockchain, and they have the power whether they want to approve that transaction or they want to reject that transaction. Secure. Again, cryptographic encryption ensures the data safely. Because of this cryptographic encryptions, it is very hard to make some kind of attack on that block and try to find out some information. Immutable. Once recorded, data cannot be changed. This is the another very interesting stuff. Suppose your business is involved, again, going back and make some changes. So that is not, you cannot use the blockchain in those cases. Blockchain, so that, it is non-changeable. Once it is done, because sometimes what happens in supply chain, when people, they initially do the transaction, they do the honestly, but after some time they go back and they make the changes in the previous records. So in order to avoid that, this is a non-changeable. You are saying true things on my face, and after that you are making some changes in our transaction. That is not going to happen in this blockchain. Okay, so once you record the transaction, you are saying that I am giving you the 100 products, and manufacturer is saying that yeah, we are getting the 100 products. That's it. After that, nobody can change that the record, transaction record. Transparent. All participants can verify transaction. So once new information is added, now what is the next step? New information is added into that network. Then in order to add that block into your blockchain, majority of the participants in that network, it could be the nodes or the computers who is doing, who is looking after that blocks, they need to approve that transaction. And there are many mechanisms available, proof of work, proof of stake, all those things. So in proof of work, basically it depends on the majority. How many participants, computers are involved in that network, and they take the majority call. If majority of the people agree that transaction is added into the network. If majority of the people reject it, that transactions won't be added into your blockchain. So that's your transparent. All participants can verify transaction. So some of the key events in blockchain technology. What is the historical background? When it was started and who it was started? What was the reason behind making this technology? So you can see here. So initially in 1991, Stuart Haber and Store Matters described the blockchain technology. In 1991, during 1990s time, they wanted to make some technology timestamp so that they can record the timestamp, the information onto that technology, onto that tool. So they started initial, work on that blockchain technology in 1990s time. But first white paper of Bitcoin and blockchain introduced with the blockchain conceptualization by Satoshi Nakamoto. Again, very interesting stuff, guys. If you look at this paper that appeared in 2008, they described the basic characteristics of blockchain, what is the use of this blockchain in financial system and other. So very interesting stuff. Okay, but if you look at the affiliation, you won't find the name of that author. Nobody knows that who published that one. The name of the author is Sudo, and the name of that affiliation is also Sudo. So currently as well, if you look at the Bitcoin blockchain, we don't know who owns it. Still, it is very popular, and people they are using for the transactions. But the initial, the thing started with this, Sudo names and Sudo paper based on the Bitcoin and blockchain by Satoshi Nakamoto. So we don't know who is that guy basically who introduced this one. Then in 2009, the first Bitcoin transaction, the Genesis block were mined. So mining is the process where you try to solve the complex equations in order to generate the new hash or new block in your supply chain. So we will talk about that Genesis block. Then in 2010, Bitcoin market, the first Bitcoin exchange is established, and the first public Bitcoin trade happened in 2010. Then in 2011, Bitcoin value reaches in comparison with the US dollar, euros and pounds. And then China Bitcoin exchange launched, the first Bitcoin ATM is also launched during that 2011 time. 2012, Bitcoin magazine first issue published open coin release. So many developments happened after that when everybody was aware of this Bitcoin technology, and then it started trading on the share market as well. Like total Bitcoin value surpasses 1 billion USD in 2013. Zero coin concept presented in IEEE S&P. S&P is basically the index in the US. Thailand bans cryptocurrency. Still many countries they haven't given the official approval of this cryptocurrency. Okay, you can do the trading and all those things, but if you go with the normal share market, you have the government's approval, everything is transparent there. But cryptocurrency, still many governments they haven't approved it as an official currency or official thing for the share market. Ethereum is one kind of your blockchain or the coin, you can say. Launch announcement on Bitcoin forum. HMRC in the UK classifies Bitcoin as a private money. HMRC is the government body in the UK who looks after the basically your share market and everything. So they define the Ethereum as a Bitcoin as a private money, and it should not be used for your regular transaction. So sometimes when these criminal gangs, when they do the cyber attacks or some malware attacks, they don't ask the money in your regular currency. They ask in the Bitcoin, blockchain and all, in some these kind of coins. Okay, to hide the what? To hide the identity. Who is that criminal gang? And it's huge amount of money again. R3 consortium formed in 2015. Coinbase opens up first US-based Bitcoin exchange. So this is Coinbase is a platform where you do the trading of this US the coins, blockchain technologies or other cryptocurrencies. Ethereum first live release. Frontier launched. Nasdaq initiates the blockchain trial as well. So Nasdaq is the another share market in the US. Linux then established the Hyperledger project. The DAO, Decentralized Autonomous Organization, sets crowdfunding record. So at one side, people were trying to do this cryptocurrency trading and all those things on unofficial platforms, but other end, currency, some companies they were trying to use this technology to improve their operations. So in 2017. Digital trade chain platform announced the US Department of the Treasury FinTech working group formed. Bitcoin sign added to Unicode. Japan recognizes the virtual currency. So Japan recognized as some countries they recognize it as an a virtual currency you can do the transactions, but some company they haven't approved it. Then Kodak announces Kodak coin cryptocurrency and blockchain. Then in 2019, Ethereum's constant tone pole hard fork is released. Facebook announces the Libra. So these are the some of the coins they introduced. Decentralized finance. And in 2022-23, central bank digital currencies. Several countries began experimenting with the central bank digital currencies to digitize their national currencies. So this is just little bit history about what happened, who has started this one, and some of the key events in this technology. Suppose now we will start to understand the basic difference between the blockchain and your normal transactions. So what is the traditional banking transaction? Suppose in traditional banking system, what happens? Suppose Venkat wants to transfer some money to say Chinmay. So Venkat requests the bank to transfer the money to Chinmay. This is the transaction he wanted to do. Then bank verifies the the Venkat's account, balance, credentials, and then they also check the Chinmay's account and the other details. If verified, the bank approves and processes the transaction. If both things are approved, they approve the transaction and they do the the payment. So that's your traditional banking system. What are the issues in this one? Tell me, what are the issues in this traditional banking system? What is our main goal? Venkat wants to transfer the money to the... Why do you go with the bank? Why don't you directly go there and give him some 100 pounds, 100 rupees? Why you are going to the bank? What is the need of bank here? Yeah, okay, that is money in the bank. Suppose, but if you have cash, you go there and you give him 100 rupees. Transaction is done. What? Yes. Accountability, trust. What else? Records. You want the records whether you officially given the money, because sometimes if Chinmay may say that I don't receive the money. Okay? And then sometimes Venkat may say that he actually gave the 100 rupees. He may say that I give you 10,000 pounds. Okay? So that's why we go to the bank. Bank look after this trust between the basically the sender and the receivers. So third party involvement. Bank is an intermediary here. Okay, so who looks after that transaction and that it creates that trust between the two members. But when you use the banks, obviously you need to pay some transaction cost. So if you are doing the online banking, GPay, they do charge you the their annual transaction fees and all those things. So high transaction cost sometimes based on the whatever the amount you are transferring. So these are the problems with your traditional banking system. Time delays. Suppose you want to transfer but your GPay is not working and there is an immediate need for Chinmay to get that money. You can't do anything there because of this, the whatever the server problems or some other issues. Blockchain based transaction. What could happen in the blockchain when you use it? Blockchain based transaction. So basically you initiate the transaction online, Venkat. The transaction is added to a block and validated by the network miners and nodes. So you start that transaction. You want to give the 100 rupees to the or 10,000 rupees to the Chinmay. You give all the details. This is my name. This is the person who is getting the money. Timestamp that the transaction, and then this transaction is added to a block and validated by the network. Then who will validate it? Who is involved in that one? You are involved, and then the Chinmay is involved. You both approve that transaction. Okay. Then miners, nodes. Nodes means who are the basically the people involved in that transaction. Once verified, so both parties verified the transaction. Then the amount is transferred to the Chinmay securely. So what are the advantage here? You are not involving third party. Transfer the money immediately. There is no time delays. Then what else? No third party involvement. Lower cost and faster transaction because of the no involvement of third party. Your transaction cost will go down. The transaction will be faster. Immutable. Suppose that transaction is done, both parties approved the transaction, and after that Chinmay wanted to make some changes in the transaction. Chinmay, you actually gave 10,000 pounds, 10,000 rupees, and Chinmay wanted to make it 100 rupees. Can you go back and make the changes in that transaction? No, he cannot go back and make the changes into your whatever the amount you have given to him. So that's unchangeable, cannot be altered. Blockchain removes the intermediaries. So when you add intermediaries, your whole system, whoever supply chain will become the complicated, unnecessary. The different problems may come, making the transaction faster, cheaper, and more secure. Cheaper means when you remove the intermediaries, their cost will not come into that transaction. So cheaper is there, more secure is there. Why? Because both parties are basically approving those transactions. It's not like that only one party is approved. All the parties involved in that transaction, they are trying to approve that your transaction. So what are the motivations behind this blockchain? Problems with the centralized system. Single point of failure. Suppose your bank server is crashed, okay, because of so many people are trying to log on to the bank's network, or again railway system. Suppose you are trying to book Tatkal kind of thing, premium Tatkal tickets, when many people at the same time they try to log on into your system, and because of this sudden demand, your the server may get failed there. So single point of failure. Centralized server, banks, railways depend on a few backup servers. They don't have huge amount of backups. They have few backup servers, and sometimes if those backup servers don't work, then their service will be affected. A failure in the main server can disrupt the entire system. Whole the system will be affected because of that main server failure. But in case of your blockchain, if one server is affected, one node is affected, only that the entity will be affected who are involved in that transaction. Other transactions, they happen regularly without any disruptions. System downtime risks. As I said, high traffic surges can overload central and backup servers. High traffic means during this premium Tatkal or the normal Tatkal, or sometimes during the one peak time. If high traffic is there, means huge number of customers are trying to access your banking the service, then your server may become overload, and then backup servers will be affected as well. Leads to slowdowns, crashes, and service outages. That's why sometimes you see, please apologies on the banking platform, or on your railway platform. Apologies, our server is down, so because of this high demand, our server is crashed, our service outage time during during the out of office hours. So those are the problems with the centralized system. Then lack of redundancy. What is this lack of redundancy? If the main server goes down, all operations stop. Okay, but in case of your decentralized ledger blockchain, if one of the server is affected, but still other servers, they worked fine. No decentralized backup to keep the system running. Okay, that's another problem with the lack of redundancy. Redundancy means you are keeping that additional backup server, so that if main server is affected, you can run with the backup servers. But they have got some backups, but only few servers, not huge amount of servers. So that's why that is the problem with your redundancy. Blockchain as a solution. So you could address these problems with the help of blockchain. How could you do that? Decentralization. Every node stores transaction acting as a backup. If suppose there are 5 nodes, 5 members are involved in supply chain, one of the node is affected because of some data breach or something, do you lose the whole information? No. Why? Because other 4 nodes, they have the copy of that transaction. In case of your centralized one, this is not the case. If main server is crashed, everything will be collapsed. That's why. But in decentralized nature, decentralize your network, each member has the copy of that whatever the transaction you have done. So if one of the members are affected or few members are affected, other members have the copy, and then you can get the information from the other members. So that is a decentralization. Every node stores transaction acting as a backup. Distributed ledger, no reliance on a single server, reducing failure risk. We can say that we have got multiple servers, just for the understanding. In centralized, we have got only one server, but here you are keeping the copy of the transaction at each node, at each component, so that distributed ledger is there. Immutability ensures data integrity and security. As I said, once your transaction is done, you cannot go back and then you cannot make any changes in that transaction. That is the nature of that blockchain. Faster settlements, you want faster settlements, that's why you go with the blockchain. Traditional banking transactions are slow sometimes because of the time delay. Blockchain significantly reduces the settlement time. Okay, it's not like that it is a Sunday, Saturday or something like that and you cannot do the online transaction. You can do anytime, those kind of transaction. Security, cryptographic function and consensus protocols secure the transactions. Security means consensus means there are different kinds of consensus algorithms, and then if majority of the people they are aware of those transactions, they approve the transaction and the whole data is updated onto the blockchain. Immutability, data blocks cannot be tampered with, ensuring reliability. You cannot make a single change in that data block or the whatever the information you are stored, whatever the basically advanced technology use. Once it is done, it is tampered proof. You cannot make any changes there. So that's why in some cases, in some industries, suppose you have a need to go back and change some changes or make some changes in that one. In those cases, the blockchain is not going to work. So you need some other database or other platform which allows you to go back and make some changes. Whatever the changes you want to make, it is for just genuine reasons or for some other reasons. But blockchain doesn't allow to go back and make changes. So that's why it is unchangeable. Transparency, no third party intervention needed. You don't need to take the approval from any third party. Why? Because the parties involved in that business, they are making their approval. They know what is happening in that network. So you don't need any third party intervention. All stakeholders can verify transaction in a decentralized system. Everybody, it's not like that suppose supplier updated some information block onto the network and distributor doesn't get to know what is happening. Everybody involved in that network, they gets the update whenever the new information is updated or the new block is is added into the your blockchain. So what are the key terms of blockchain? Any idea? Have you heard anything? What are the key terms of blockchain? Ledger, okay. What else? Consensus, protocol, proof of work, proof of time, proof of stake. So let's see some of the key terms that we use in the blockchain. First is the nonce and mining. Have you heard this term, nonce and mining? So nonce, a random number used in mining to generate valid hashes. I will tell you hash as well. What is the hash? So nonce is a random number, because when first block is generated, you get the previous hash, some part of the previous hash, okay, and then you make the second block. So when you make the second block, the consensus mechanism, proof of your work, you need to solve one complex equation there, complex equation with the help of your previous the hash available, and then you have some your own keys. So in blockchain you get your own private key and public key. Okay, so you use your private key, public key, whatever information available. You use the previous records of the hash, and then we use this random number used to generate some valid hashes. So random number, we will see the application of this one when we play that blockchain game. Any doubts so far? No? All clear? Started? Okay. Consensus done hard fork, a rule change that alters block validation. Suppose when you try to solve that complex equation, suppose two groups or two nodes, they find out the answer exactly, so then you can change that rule. Occurs when two miners find a block simultaneously, leading a network split. So you can change the rule how you want to add that block into the blockchain. When two nodes, they identify that hash simultaneously, then you cannot give the reward to any one member. Okay, then you can change the rule of adding the block into the blockchain. Again, Merkle tree. What is this Merkle tree? Also known as a hash tree. Okay, so here each leaf node, hash tree, it includes the different hashes. Each leaf node contains the hash of a block. Okay? And with while non-leaf nodes store the hash of their child nodes. Okay, so that is called your Merkle tree, where you get the information of all the hash of that blocks. Node. What is node? Computers in the blockchain network are called nodes. Suppose there are 5 nodes are there, means each node is for one entity. Supplier, there is a one computer. For manufacturing, there is one computer. Then distributor, retailer. So how many computers are available, or how many stakeholders are involved in that network? That is called node. Computers in the blockchain network are called nodes. Each node maintains a copy of the ledger. Each node means each computer keeps the copy of that the ledger, whatever the transaction you are doing. Nodes validate transaction and ensures integrity. As I said, nodes means you are saying that majority of the people, they approve the transaction, means nodes means computers. They approve the transaction and then they ensure the integrity. Transaction. What is transaction? Simple. Smallest unit in blockchain containing records, data and information. So in your block, transaction means smallest unit, who is the supplier, who is the receiver, how much products you are sending, what you are sending, what is the quality of that products. It contains the records, data and information of that transaction. Includes sender and receiver details along with the transaction value. Suppose Venkat is sending some money. Who is the sender, who is the receiver, how much he is trying to send, all that information. Uses digital signature for security and timestamp. So you need to approve it. You cannot just verbally call and say that, I approve it. So you need the digital signature. So it uses the digital signatures for security, and again it is timestamp, so that you can see when that transaction is approved. Addresses. So unique identifiers for senders and recipients. So when you do the transactions in this cryptocurrency, so there is an address each for senders and the receivers. A public key serves as the blockchain address. So there are two kinds of key. Public key, which is available to see to everybody involved in that network, and the private key as well. Private key, that is only for you. Once you lose that private key, what will happen? You cannot claim your blockchain asset, whatever. So that private key is basically your blockchain wallet. Okay, so whatever the cryptocurrency blockchain, whatever the coins you are keeping into that one. Once you lose that private key, you cannot claim that blockchain asset. Public key is available for everybody. What is the use of public key? With the help of public key, they can approve the transaction. Block. Block means it contains transaction details such as timestamp, when this transaction happened, previous block link. So the hash of the previous block, you need to use it for creating a new block. It uses a secure hash algorithm to ensure the integrity. So each block, they use this hash algorithm to create that integrity in the blockchain. consists of two parts. So each block, it includes two parts, block header and block body. So what is that block header? So block header, basically you see the information, block body, then you have the main components blockchain. Chain block, it includes the transaction, your timestamp, previous block. Chain means when you connect the blocks, sequential arrangement of blocks creating a link structure. So you create those blocks interlinking with the previous block. So that's called your block and the chain. When you connect those blocks, it becomes the blockchain. I will show you some examples of how each block looks. Cryptography. Definition: cryptography protects information by encrypting and decrypting data, ensuring security and trust in blockchain networks. I hope you know what is encryption and decryption, and they use this encrypting and decrypting the data to maintain the security of your blockchain networks. What are the key roles of this cryptography in the blockchain? Hashing, used to link blocks and maintain consensus. So you see this hashing algorithm. What is this hash? So basically it is used to link the two blocks, and then it maintain the consensus in your blockchain. Asymmetric key cryptography identifies users and proves ownership. So this is, as I said, your public key, private key. With the help of private key, you can identify who is the owner of that blockchain, that asset, and proves the ownership as well. Trustless environment, it eliminates the third-party intermediaries. Because of this cryptography, you don't need any third party to approve that transaction, to make sure that this transaction is safe, and it is not any tampering has been done there. Hashing in blockchain. Hashing converts data into a fixed length unique hash value using cryptographic algorithms. So there are some cryptographic algorithms you can see here, SHA-256, and we use these algorithms to convert the data. So suppose in one block, when Venkat sends the money, who is the receiver, who is the sender, and how much money they are transferring. So this information is there. So you need to convert this information into the hash. You need to convert this. You cannot simply write there, okay, sender is Venkat, receiver is Chinmay, and he is transferring 100. Is it safe? Everybody sees who is the sender, who is the basically the receiver. So here hashing converts that data available, data stored into that block, into a fixed length unique hash using cryptographic algorithms. What are the features of this hashing? Unique identification of data for each data. Suppose he is saying that 100 rupees is transferred, or 100 pounds is transferred from Venkat to Chinmay. So that 100 amount, it will create the unique value in that hash. If you change that value, if you make it 150, that hash will change. Okay, so it depends on, that's why I am saying that. Why you cannot change the value once the transaction is done? Because whatever that hash you are developing, it is based on the available information in that block. When you change the information, then only hash will change, and it is very, very complicated. I hope you haven't, if you might have seen the whole the hash of any blockchain technology or Ethereum, some 16, 17, so many complicated stuffs are there. So in blockchain, for example, in Bitcoin, if you see 16 times the 00 will come, and then after that transaction details will get started. One-way function, irreversible, secure linking of blocks, Genesis block to latest block. Genesis block is your first block, and that blocks then you connect with the rest of the blocks in your network. Examples of hash function you can see. So our input is blockchain. This is the input you want to, and now you want to convert into the hash. Output 81C, 885, blah 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 blah, and so on. So if you make small change in this blockchain word, suppose blocks and chain, if you make that small c as a capital T in blockchain, this is the your sixth letter. Okay, if you make this small c into the capital C, the whole output will be changed. So that's why when you make this, when you convert the raw data into this, unique hash, you cannot, you need to be very secure there. You need to be very confident to make sure that you are using the exact information to convert that raw data into the hash. This is another example. Data, blockchain concepts, book chapter. This is your input data. Now you wanted to convert into the hash. This is the hash. Can you remind this? Can you remember this? Is it very difficult? You can see. And now what you want to do? You want to change this book, the first alphabet letter, you want to make it small b. And then see. So even you make that small change, blockchain concept book chapter, your whole hash is changed here. Then do you think that you can go back and you can make the changes in that record? It is very difficult. Why? Because whatever the small change you make in that transaction, once it is approved, the whole block will be whole hash will be changed. So that's why we call it as tamper-proof, secure, transparent, and unchangeable. Block structure, you can see the block height here. Okay, header hash from previous block. So your first block is Genesis block, and then you take the hash from this previous block, and then you create the second block. So in this block, what you see, previous header hash, the hash from the previous your block, timestamping when this transaction is happened. So that is the information you want to store here. What is the difficulty? Difficulty level means how complicated that hash is there. Merkle root, the hash tree, okay, and then transaction, and then after that, this information will be passed to the next block. And then, so you can see this is the whole network. This is your first block. Then hash will be transferred to the second block, and the not whole hash will be used to make the second block. Only the part of that first hash will be used to create the second block. Then you have got the third block, and then n number of. So what is the block content? You write previous hash. So for example, your previous hash is 0, and then your timestamp when that transaction is happening. You are saying Monday 6th of August 2009, 2 o'clock GMT time. So this is the timestamp when that information, when that transaction is happening. Data, what is the data? So this is a welcome to blockchain. Just one example. But in your case, the data is that you are giving 100 rupees to the Chinmay, or that is the data. Hash, this is the hash. What is it based on? Is it based on the data? This welcome to blockchain. You change this input data, the hash will change. And then nonce is, what is this nonce? A random number to solve this difficulty, means mathematical equation. This is the random number 45673 to solve that your mathematical equation. Header, it contains the metadata. So what is that metadata? Hash of the previous block. Hash of the previous block. Why do you need the hash of the previous block? Why do you need the hash of the previous block? To make it continuous, interconnected. Do you use that hash for any purpose in this new block? For accessing public key, yes. So when you solve this mathematical equation, you need the previous hash. Without that, you cannot solve that mathematical equation, and then that's why you need that hash. If the previous hash is not correct, what do you think? What will happen? Whatever the equation you are trying to solve, it will not get approved, or you will struggle to solve that. So that's why if previous hash is not correct, your new block will be affected. Timestamp. Again, you can see here when that basically the information or the transaction happened. So timestamp you can see here. Nonce, random number for mining. You want to solve that equation here using the previous information, the given information here. So we need the random number to solve that one. So that's a nonce. Merkle tree root digital fingerprint of transaction. So this is a digital fingerprint of transaction, means all the hash you can see in that Merkle tree root. List of transaction records all the included transactions. So here transactions in one block, you can add single transaction or you can add multiple transaction, based on when you do those transactions. Block identification, block hash, unique hash ID generated for each block. So what is hash? Unique hash ID generated for each block. So this is a unique ID, and this is you cannot change this because it depends on the input information, it depends on the previous hash. So this is a unique hash ID, and then I have shown you the example as well of this unique hash ID on the previous slide. So this is a hash ID. You cannot change it. Why? Because it depends on the input information available, and then if input data is changed, then only this will change. Otherwise it will be difficult to update this your unique hash ID. Records all included transactions. Block identification. Block hash means unique hash ID generated for each block. Block height, position of the block within the blockchain. Block height, it shows the what is the position of that block in the blockchain. Suppose you have got the 5 or 10 blocks in that network. So block height, it will tell you that whether what is the exact position of that block in the blockchain. Merkle tree ensures the data integrity by linking transaction in a hierarchical structure. So it basically tells you the hash, all the hash IDs, and it will link the transaction in a hierarchical structure, like which transaction happened first, and after that what is the next transaction. So that linking of the transaction is normally done in the Merkle tree. It provides a secure and efficient verification process. You can verify that transaction there, and you can make it secure as well. Blockchain formation. How does then blockchain we make it? We create. Each block contains a reference the previous block's hash. As I said, if you look at this block 2, this includes the information or the previous hash, and then each block contains a reference to the previous block's hash. Then you use the mathematical equation considering your random number to solve that one, and when you solve it exactly, if it is correct, then everybody will approve it. And if you solve that mathematical equation and if it is wrong, what? Other parties, stakeholders, they will not approve it. So this is exactly the understanding. So in supply chain perspective, transaction is wrong means you are saying Venkat gave 200 rupees and you are making some changes like 500 or 600. So this is a wrong information. So other members, they will not approve that transaction. So here, when you solve that, basically the mathematical equations to get that nonce. So if it is correct, then everybody will approve it. If it is wrong, nobody will approve it. Creates a secure and non-changeable, immutable chain of blocks. That's your blockchain. Each block contains the information about the transaction, then it includes the hash based on the input data, then you use that block to create the another block when the new information is added. How blockchain works? Any idea? One and a half hour. Is tree already there outside? Okay, yeah, we'll take the break and then we will start this. No, 3 hours. He said? When did he say? Okay. Let's see, we'll do. Blockchain types. Is tree outside already? Okay, yeah, we'll take the break then. It came? Is it working fine? Okay, so we were talking about the blockchain, how blockchain works. So we initiate the transaction initially. The user initiate this transaction. That includes contracts, cryptocurrency records, or you want to share that records with the other members of supply chain. So we initiate the transaction. Once we initiate the transaction, next is to create the block of whatever the record you have got, whatever the content information available with you, and you want to share this information with blockchain, with the help of blockchain, with the other members in your supply chain. So the transaction request is represented as a block in your network. So you can say that new transaction is requested within a new block, and this block broadcasted to every node in the blockchain. So disseminate block. So once block is created, now you need to broadcast that block to the all the members involved in the supply chain. For what purpose? So that they can approve that transaction. Okay, approval. So the block is created and shared with the network participants. Who are the participants? All the nodes involved in that supply chain. You share that block, and then those, you can say, the block is broadcasted to every node in the, you can see here 6 nodes are there. So everybody can access that block, what is available there. This is a non-localization. So we are not keeping that block in a central any servers or central localization. So here we are doing the non-localization basically. Then block validation. Participants analyze and validate the block. So once this is done, broadcasting is done, the majority of the nodes approve the validity of the transaction. Now you want block is broadcasted to everybody. They know that what is that transaction, what is involved in that transaction, who is the sender, who is the receiver, what is the quantity they are sending. That is done. Now next thing is the approval. So how do they approve it? With the help of some consensus algorithm, contract. So participants analyze and validate the block. So in proof of working consensus algorithm, if majority of the, suppose here 6 nodes are there, if 4 nodes approve this transaction, new transaction, that block is added into the blockchain. If suppose only 2 members approved it and 4 members rejected it, this new block will not be added into the blockchain. Okay, so the block is, once if it is majority of the people approved it nodes, the block is added to the blockchain, and then a new copy of the ledger is saved in distributed networks. So in all the networks, new copy of this distributed ledger is created. Why? Because you added the new block. So then in the existing chain, that new block will be added, and the new copy of this transaction, it will be created, saved in the distributed networks. So when they approve it, how does it work? Smart execution. The verification process and adding new transaction to the ledger can be executed by smart contracts. Smart contracts means basically the rules. You know, how do you want to approve that transaction? That's your contract. Consensus algorithm, validation is done using a consensus mechanism. And there are various kinds of consensus mechanism. Validation for attachment. Members validate the block to add into the network. So once block is verified, it goes into the blockchain network. Block attachment, the validated block is added to the blockchain. So this is the way the blockchain works. So now let me and then immutable and permanent. Once added, the block becomes permanent and non-changeable. So once the block is added into the network, you cannot make any changes in that block. You cannot go back and make any changes here. See the supply chain example. how the blockchain works. Initiate transaction means transaction start with the shipment, contract or delivery details. Suppose you are doing the shipment to your distributor, retailers. So that shipment is basically the transaction. That includes the tracking number, shipment details, how many products are there, when you are doing that shipment, who is the receiver, who is the third party logistics provider, who is the fourth party logistics provider. Block creation. Once that, after that initial transaction data includes the shipping date, product details is packaged into the block. So block includes all these details: who is the sender, who is the receiver, what is the quantity, what is the amount they are transferring. So shipping date, product details. So you create that block. Block is created. Now next, disseminate. Disseminate means broadcast this block to the all participants involved in your supply chain. The block is shared with the supply chain participants, that is supplier, carriers and retailers. So who is the supplier? Suppliers who which are supplying the products, retailers who are taking that products, and carriers, third party logistics providers. They should also aware of what is being transported and what is the quantity, product details, shipment details and all those things. Block validation. Then participants who will approve that one: warehouse, transporter, retailer. So basically the supplier, the retailer, the transporters, third party logistics provider or fourth party logistics provider, they verify the transaction accuracy. Because if I am a supplier and I am adding the exact information on that block, so my retailer, that retailer is also aware of what I am sharing. Logistics partner, we are also involving the logistics partner. So when all these participants, they approve the transaction, then it will get validated. After the for validation, consensus mechanism ensure the agreement on transaction validity. Suppose out of these suppose majority of suppose warehouse and retailer, they approved the transaction, and if transporter didn't approve it, so majority is there, so the block is get added into the basically your blockchain network. Validation for attachment. The block is validated and approved for the blockchain. Block attachment. The block is added to the blockchain network, confirming the transaction. And then once the transaction becomes permanent, providing an unchangeable record. So this is a way your blockchain works in the supply chain and logistics area. So there are two kinds of network architectures. So one is with your centralized system like bank, central architecture, and another one is the distributed one. So first is we are going to see some differences between your network architectures: client and server systems and peer-to-peer network. So in blockchain, which one do you use? Peer-to-peer network. So client server means centralized model where a server manages resources and services. For example, bank, government bodies, they have got this client server system, server, and then you have got the clients which try to access the information with using the server. Peer network, peer-to-peer, decentralized model where all nodes, peers, have equal roles. So all nodes, they see this basically the new blockchain or new block added. So this is a decentralized model where all nodes, they see the transaction and they have equal roles to approve that or reject that transaction. So in clients and server system, client send the request, the server processes and responds. So your banking transaction, clients means one person want to transfer the information, that person initiate the request, then server process that request and respond to it. So that's your client server model. Then you have got peer-to-peer. No central server. Here we don't have any central server. Peers communicate directly via message passing. Okay, so basically supplier, all the members involved in that supply chain, they directly communicate with the other members of that network, and then they manage the transactions locally. So there is no central server involved here. Basically peers communicate directly via message passing. Used in enterprise applications, cloud computing and databases. Used in client server means enterprise application, cloud computing and databases. Then used in file sharing. Peer-to-peer means file sharing, BitTorrent, blockchain and cryptocurrency networks. They use peer-to-peer. What are the limitations of client server? We already talked about a couple of things. Single point of failure. If the server crashes, the whole system fails. Higher maintenance cost. This is the example of your server, and you have got one server, the 4 computers are connected, 4 nodes are connected. Then peer-to-peer advantages, no single point of failure, more resilient. And we have got the backup, additional copies of the records as well. Better scalability and efficiency. We can very easily scale this peer-to-peer network, and it will be efficient as well. This is a network, so you can see 5 computers are there, 5 nodes, they are interlinked with everybody, and then they can directly do the communications, and you don't need any third party or server to approve those transactions. There are some types of blockchains. Yesterday we talked about the IoT types. What are some types of IoT? Consumer IoT, commercial IoT, industrial IoT. So similarly, we have the blockchain types. What are the blockchain types? Public blockchain. Public blockchain, there are some features of this blockchain. Permissionless, open to all participants without restrictions. Suppose government is using the this kind of blockchain to share the information with the other members, with the normal public, but they want to make sure that nobody can change any changes into those records. So permissionless, open to all participants without any restrictions. Features full rights to read, write, and maintain the ledger. So you have got all the nodes, they have got full rights to read, write, and maintain the ledger. Trustless and immutable, records are permanent and trustworthy. We cannot make any changes there. Examples, Bitcoin or Ethereum. So these are the example of your public blockchain, where information is available to all the participants who are involved in that network. Everybody has the rights to read, write, and maintain that ledger. If I buy one Bitcoin coin, so I can see that what is my hash code, hash ID, who are involved in that one, everything. So records are permanent and trustworthy. And similarly, Ethereum is another coin. Then public blockchain. What is next one? Private blockchain. Permission, access restricted to selected participants. Suppose there is a confidential information involved in your supply chain, and you want to make sure that only the authorized people will see those information or data. Then you can use the private blockchain. Like I just said, now in the game you will get one private key and you will get one public key. Okay, so private key, basically it is your blockchain wallet, where you keep all the information of your blockchain wallet. So access is restricted to selected participants, not everybody involved. But in public blockchain, everybody has the access. Features, transaction records are encrypted, accessible only to authorized users. Use case, ideal for internal trusted networks with identity management. Examples, Hyperledger Fabric, Corda, or Quorum. So these are the examples of private blockchain, and we use these blockchains where you want to transfer the restricted information to the selected participants. Hybrid blockchain, the combination of your public and private blockchain, merges features of both public and private blockchains. Structure, semi-decentralized, semi-private, suitable for cross-organizational use. Means suppose you want to do the cross-organizational collaborations, you can go with the hybrid blockchain, where you can do the semi-decentralization, you can share some information, you can make some information public. Control user group with public and private benefits. So these are the 3 types of basically the blockchain: public blockchain, private blockchain, and hybrid blockchain. So these are some of the properties. Public, consensus algorithm, permissionless, we don't need any consensus to approve the transaction. Private, we need the permission to approve the transaction, only authorized users are allowed. Consortium, permission only. Efficiency, public low, private high, then consortium again high. Determination of consensus, all miners of the block will be participating. Public means all the miners, all the nodes in that network, they will be participating. Here private, users of one organization will be participating. Why? Because of the private nature of that blockchain, only the selected participants will participate there. Consortium, selected set of nodes only will be participating. Read, public, open to public, anyone can read, write and maintain the ledger. Here can be public or restricted, can be public or restricted. Immutability, tampering is not possible in public. Private, possibility of little bit of tampering because of the involvement of the selected participants, and again consortium, possibility of little bit tampering. Generations of blockchain. If you look at the blockchain now, how initially it was started and now what are the some of the coins available in this blockchain. Examples, first generation, initially the Bitcoin, Litecoin and Ethereum, those kind, Bitcoin and Litecoin, they are your first generation blockchains. Consensus mechanism, proof of work and proof of state. So these are the mechanisms we are going to talk about that. Energy requirements requires more energy. Why? Because you need the more power to solve those complex problems for the consensus algorithm, for consensus. And then here requires less energy as compared to first generation. And then third, Cardano, Nano, very low. And fourth is still in the development stage. So provisions for variable consensus mechanism. So here the energy requirements is low. Energy requirements means how many nodes are available in that network, what information you are trying to share, and what is the consensus mechanism. So depending on those factors, the energy requirements is decided. Cost, Bitcoin high cost, Ethereum medium cost, then Cardano is low cost, and again fourth is cost effective. Smart contracts, no control over the transaction, unavailability of smart contracts. Smart contract is one of the feature of your blockchain. So in first generation we cannot do that smart contracts, but in Ethereum now you can do the provisions of smart contracts, dApps. Third, support smart contract with the intrinsic verification mechanism. Scalability challenges, uses Lightning here, and then can use sharding for improving scalability. Speed, Bitcoin, it is a time consuming because again the huge amount of data, more energy. Ethereum is also time consuming. Cardano, these are the very low energy requirements, so that's why speed is high. And again fourth generation, the speed is very high. Consensus mechanism. What is the purpose of consensus? To approve the transaction or block. Proof of work. The principle is too difficult to solve but easy to verify. So here in proof of work algorithm or consensus mechanism, we solve the mathematical complex problem to approve that transaction to find out the nonce. Process, new nodes created by solving complex problems. Suppose new node or new blockchain is added. So if that platform is following the proof of work, then each node they need to use the previous hash random number and the information available to solve that equation. Once you solve it, then you get the correct answer. Features, computer intensive, you need huge amount of memory to solve those complex problems because you see the hash ID. It is very complicated and you need to find out what is inside into that hash ID. It requires significant power. This is your proof of work. So in initial generations like your blockchain, Bitcoin, Ethereum, they use the proof of work, but now some other consensus mechanisms are there. Proof of stake. Principal validates stakes Ethereum. ETS means ETS to participants. So here, in order to participate into your decision making process, consensus mechanism, you need the minimum ETH. ETH means Ethereum. Minimum 32 ETH to become a validator in that proof of stake. Process, validators randomly selected to create and validate the blocks. Then third one was the delegated POS. It is similar to the proof of stake, but it follows the election system to select witness nodes. So it follows some witnesses. It doesn't consider all the validators here. So that is why delegated POS. Process, witnesses verify blocks instead of all validators. So in delegated, only selected members nodes they will participates into the consensus process. Not everybody involved into that mechanism. Proof of elapsed time. So it is based on the random waiting time for mining rights. So process first node to finish waiting gets to commit the block. So first node who finish the waiting, they are able to commit the block. So these are the only couple of consensus mechanism. But if you look at some advanced literature or recent literature, you may find some other consensus mechanism as well. This is also the based on the recent research article. Blockchain versus traditional database. So characteristics: traditional database, client server. Here peer-to-peer. Authority in traditional databases, centralized. Here distributed, decentralized. Control in traditional one, administrator, your bank, government policy. Here public, permission, hybrid. Disintermediation, data is centrally administration by the DBA in traditional. But here trustless and decentralized, no need of intermediate to validate and authorize to store the data. You don't need any third party to approve or to authorize the data. Robustness, here single point of failure. If your main server is down or crashed, your whole system will be affected. Here no single point of failure or control. Audit trail of all the data instances. Here history of records, ownership of digital record not available. Data can be updated and modified going back. But here history of records and ownership of digital record is available. Data is traceable to its source. You can trace from where that product started its journey, who are involved into those journeys. A new block added to any new addition or modification. Data handling, data storage. In the traditional we store the data in tables, but in blockchain we store the data in blocks. Public verifiability, data integrity is lower. Here transparency is maintained. Again here transparency, database administrator decides what is visible to the public. Here public blockchain supports data transparency. And then data persistence, non-persistent in traditional databases, and blockchain it is immutable. Blockchain platforms, Bitcoin is the very popular and famous blockchain platforms. The type is first cryptocurrency based on the blockchain. Bitcoin consensus, it uses the proof of work. Architecture single chain. Programming you can do in C, C++ and other languages. Ethereum another platform. Open source platform for smart contracts and decentralized apps. Network public and open source. Programming support Solidity. Features faster processing and private transaction within the permission group. So there are many platforms are available, like Hyperledger is there, open source, cross-industry blockchain platform by the Linux. Use cases, finance, banking, manufacturing, you can use the Hyperledger technology or Hyperchain platform. Components include Bureau, Fabric, Grid, Indy, and so on. Hyperledger Bureau, permissioned modular blockchain client, features. Now it's time to learn how exactly blockchain works. I need 7 groups. So you distribute whatever you want to 3, 4 students, but I need 7 groups, no more than that and no less than that. 7 groups. And make some distance between each group, like at least make some keep one bench distance from your nearest bench. Why I am saying keep the distance? Because I am giving you some confidential data. Okay, confidential data, that is your private key. It is your blockchain wallet. Okay, so if other team, if they see your blockchain key, then it will be problematic for you. You would lose your asset. So that's why I am saying that I need 7 groups. Can you come from this first column in this side? You can sit onto the one bench, that's fine. 7 group. Yes. Where is the group 1? Sorry? Yeah, it will be varied. So don't worry. There is no requirement like 1 or 2 students. Yeah, that's fine. Group 1, group 2. Where is group 3? Make some distance, because if I give you the key and if the next group, if they see your key, and then it will be problematic for you. That's why I'm saying that the second, you can come forward on the first. Keep some distance between 2 groups so that the other group cannot see the private group. Come front, the second group. Come. So this blockchain game, it was designed by J. Scott Christensen's son. So he is an associate professor at Missouri University in the US. And the purpose of this game is to understand basic stuff. How does blockchain works? First group, second group, third group. Girls, 2 girls. Can you? No, otherwise you go there. First, second, third. This is 4th group. 2 people. 4th, 5th, 6th. Again we need 4 people. We want 7 students. You do one thing. 4 of you to make the another group. Go back. Yeah. You need minimum 7. Minimum or maximum, maximum. Join in, somebody. First, second, third, fourth, fifth. This is 6th group. That is, this is first one, this is second, third, fourth, fifth, sixth, seventh. Again, you are 5 in this way. Make it another. So 2, you come here. One, 2, 3, 4, 5, 6. Last 2 students, you are 7th group. Okay, you can sit on to the one bench, because you need to solve the problem here. So you need to work together in a group, and you need to solve the problem, the mathematical equation. The group who will give me the answer first, that will be the winner minor for that one. Okay. So blockchain basis, we know distributed ledger, no central server or authority. Everyone as a node, as known as node on the network, has a copy of the ledger. So each person, each team has a copy of the ledger. A huge variety of information can be stored on a blockchain ledger. Huge, it's not like only limited information. You can keep huge amount of information on blockchain ledger. Distributed ledger can store financial transactions. All the transactions happen in last 1 month, 1 year, you can keep there. Property records, shipments and inventory. In fact, you can keep the grades as well. Nowadays, sometimes if I am a teacher, I mark your answer scripts and I send the grades to the central registrar or registration system, where they keep the records of all the grades. Why do you send the grades there? I can keep the record of the grades, and it is transparent, safe, and secure. So we are going to see how this blockchain will work in the grade system. Suppose I want to store the grades in blockchain, okay? And you want to, I will give you the keys, the block, and then we will see how we can make the blockchain of that storing the grades. Distributed ledger for grades. All teachers calculate student grades and then enter to the grades into a central repository. So this is your traditional approach. Why not eliminate the registrar? Why do you go and store there? Why don't you keep the local copy, which is tamper-proof, the unchangeable? Just have the teachers maintain the ledger of grades. Let's try it. Everyone in the class will act as a special nodes called minors. So we have got the 7 group here, and you are the minors, nodes. I will pick up 7 people to be students, means we are, instead of 7 students, I am saying the 7 groups. Student identities are concealed. Each student has a public ID that matches with a private ID. I will give you the IDs, your public ID and private ID. So public ID will match with your private ID, that only the student knows, and you only knows that private ID and public ID. So first is fine. Why? Where is first group? This is your copy. Keep it confidential. If you lose it, that is fine. That's fine. Public. Because first, basically, block we are trying to create is the census. This is your second. Third one is what is written on that one? There is one public key and there is one private key. So don't worry about this one because for first block everybody knows what is the public key and what is the private key. So your group number 4. Keep the copy of this one. Group 5. Keep the copy of this one. Group 6. Keep the copy of this. Group 7. So you have got one public key and private key on your student ID. So now we want to create the blockchain to store the grades. We want to create the blockchain to store the grades. So here you can then use any of the grade scanning tools to review the blockchain, retrieve your grades. Okay, this is your public key and private key. So this is the first block. Course parks. Okay, let me. I forget to add. You need the another block as well. Blocking information. This is the tool or the page where you create the block. So block 1, course is Sparks 320. This is the name of the course. Student is AD59DA. What is the grade? Fail. Grade is fail. So now we want to create the block for this information. So you have got two basically copies. One is your key, private key, and the public key, and this is the second table basically where you create the block. Okay, so what is written there I will show you. Let me show you. Okay, so this is your first block. Okay, so basically let me show you a bit. So this is your student handout. Okay, and you can see some information there. So block, we have got the we need to create the blocks based on the courses. So we have got couple of courses available. Student ID is given, grade is there. I will tell you what is the grade. What is this NOS? What is this NOS? Random number from 1 to 3. Okay, A, B, C. What is that? I will tell you. Value of, and then this next column is value of last 2 digits of previous hash. This is the previous hash, and the value of last 2 digits is 1, 2. We are taking that 1, 2 here and divide the number. So how do you calculate the hash here? You take the this A, the number. What is A? Value of the first letter of the course. Value of the first letter of the course. So tell me, what is your first course? Park 320. Then what is B? Value of the first letter of the student public key. So you have got the public key and private key. Now use that public key. What is the first letter of that key? Then go to this lookup table, find that first letter and take the relevant corresponding number. C is the value of the grade. Again F, where does it come? F is 70. So nonce is the value between 1 and 3 that you will adjust to calculate a hash that can be equally divisible over 3. Now use your pen and tell me what is the the information for this first block. How do you do it? Tell me. Course is Park 320. Write down in your student handout note. Course is Parks 320. What is the student ID? What is the student ID? Depends on the group. Depends on the group. So student ID for the first group, we know the student ID. Student ID is AD59DA. For block 1, this why I am showing this information? Because block 1, the information is available to everybody. That is called Genesis block. If everybody there, if they are not aware of that block information, how they can make that block? So, what do? Tell me the number now. Do the calculation. Student, you know, grade, you know, A, B, C, you know the value of the previous hash. The team which will tell me this hash, that will be the winner for this block. $207. Okay, we got one answer, 207. We will decide rest of the 6 groups. 207 is correct. 207. That number should be divisible by 3. This is the requirement. Whatever the hash you are creating, that number should be divisible by what? 3. So we got one answer, 207. What do you think, rest of the members, nodes? Do you want to agree this one? Do you want to approve it? Come on guys, so you know the student number, you know the grade. Select the nonce, the random number. I am just asking for first block, don't do it for the whole thing. Okay, so 204. Listen here. Stop your calculation. Listen. Stop your calculation. The first team said that 6 number 207. Do you approve that one? No. Okay, you are saying 20. So first team said 6 number 207. What else? Raise your hand if you approve that one. No. Raise your hand if you approve that 207. There is nobody is approving your hash. Okay, that's cancelled. The next one. 204. How many of you approved it? The rest of the 6 team. The answer is 204. He is saying. The rest of the team approve. Raise your hand if you approve that hash. 204. Come on, team number 7. Do you approve the 204? No, you don't approve it. Okay. What about team number 6? Do you approve it? It's very easy, guys. I don't know why you are taking so much time. So, you know the A value of the first letter of the course. So, the course is Park 320. So, what is the letter? Park P. 80. 80 will come here. B means value of the first letter of the student public key. So, whatever the public key. What is that public key for student number 1? Public key A. So, A. In front of A, 65. 80 plus 65. What is C? Value of the grade. What is F? F means 70. So 80, 65 plus 70 minus 12. Minus 12. Then you need to select the random number from 1 to 3. But whatever the hash you are getting, that should be divisible by 3. So somebody said 207. So is it divisible by 3? I don't know which random number did you use. Did you use 1, 2, 3? 3. So you said 3. Then how did you get the basically the 207? By putting all those information. So do you think that 207 is correct one? It is not correct. Then what is? So 3 he has selected. Who has selected the 2? Random number 2? Has anybody selected random number 2? No. Then you selected 3. Oh, sorry, 1. 1. So when you add the select the random number, when you add this, the number you will get 204. That is divisible by 3. So let me show you here. This is your first block. 1, 2, 3. You want to randomly select it. 1, 2, 3. What? 1, 2, 3. From 1 to 3. Random numbers should vary from 1 to 3. But you want to select such a random number, whatever the hash is coming, that hash should be divisible by 3. Okay. So course is Sparks 320. Student is AD59DA. Grade is 5. Miners will solve a puzzle to create a unique number of the block. That is a hash using the information contained in our block, and they use that to make our ledger secure. First to generate a correct hash wins. So you generated the correct hash. So you are this first group. This is the winner of that first block. This is the winner of the first block. Other miners and node will verify if that hash is correct. when that 6-number group said 207, I asked you whether you approved of it. Okay, so if majority of the people approve it, then we take it as is. But sometimes again you need to make sure that that is what they have done, whether it is correct or not. Suppose if that 207 it is a wrong hash, and if majority of the people will approve that transaction, what will happen? You are entering the wrong information. Why? Because 207 is not the information for that whatever the data is given. So hash, it represents the information given in that block. If wrong hash is generated and if nodes approve that hash, what happens? Blockchain will not work. Got it? So the correct hash, you need to approve it. Other miners and nodes will verify if that hash is correct. Now do it fast. Has everybody understood it, or shall I repeat it again? Answer I will tell you. Answer is the nonce random number is 1 and the final hash is 204. Random number, you put all 2, 3, but it will not get that number that will be divisible by 3. You can do it. You can put the random number 2, you can put the random number 3 and do the calculation. The number, the hash that you are getting, it will be not divisible by 3. So 204 is the correct hash for that blockchain, for that initial block. Now this is done, basic stuff. Now you have got additional 6. Now do fast. Have you understood it? Now it's time to make it fast. Now I will tell you the student ID, the code and everything, and what you want to use from the previous block. So here 2 and 2. So last 2 digits will come here. So now what you have got here, hash, what is your hash? 204. And what is the last 2 digits of that hash? 04 will come here. And now I will tell you the course, student and grade. Then you need to do the calculation and you tell me the hash. Once I get the first hash, the rest of the members, they need to decide whether that hash is correct or not. So whenever we get the hash, stop working and approve or reject that hash. Got it? Shall I show you the second student and the course? So this is basically the information about the first one, value between and lookup table. First block 80, 65, 70, 12. When you add the random number 1, your hash is 204. Okay. So last digit is 04, means 4. So that 4 will come here. Now we want to create the second block. This is your second block, and tell me the hash now. Do it fast. New block, the group number 4. Look at this one. New block. Course engineering 300. Student ID this one. Grade is this one. Tell me the hash. 198. Rest of the group, stop your working. 198. Is it correct or not? 198. Is it correct? Approve it or reject it. Each group. Approve it. What happened? Approve. You haven't done the calculation. Group number 4. You have got the answer here, 198. Is it correct or wrong? First group. Is it correct? What is the random number you used? 1. So majority of the members nodes, they approved that transaction, means that is correct one. Look at the second block. This is your course, student ID, grade B, random number used 1, 69, 66, 66 from that lookup table, and the last digit is 4, and the hash you got 198. Why you are taking so much time? What is difficult here? Sorry? 204 for the second hash. Why is it coming 204? Did you use this last digit? 4. Did you use this last digit? You can try. You can place the 1 first, random number, then 2 and 3. Whatever the number you are getting here, that should be divisible by 3. If 204, how does it come again 204? Do the calculation. 69 plus 66 plus 66. Then plus this nonce. Then minus 4. Value of the B will be 0 all the time. not public ID. For ABC, you need to look at this table. For ABC, you need to look at this table, look up the table. Got it? You need to look at this table to get the values of ABC. This is your lookup table. Done? Now we want to create the third block. Got it? Shall I tell you the course and student ID? Do it fast. Are you ready? This is the block 3. Business 200, student C64445, grade C 102. 105. 105. Yeah. Are you approving 105, guys? 105. Is it correct? Approve or reject it? They corrected it then. They corrected it. 105. What do you think? I think fourth group is struggling little bit. What's happening? 200? 1. Okay. So here we got 105 and 201. 201. What is the majority here? 201. 201. You what? 6. 105. So raise your hands who is approving the 105. 1, 2, 3. What is third group? What's happening? Third group. 105. You just need to look at the letter first. Business group, then student group C, B plus C, then grade C, again C. 105. 105. Then first group, what happened? 204 you were saying, am I right? 201. Okay. So third, our block is business 200 course, student ID is C67445, grade is 7, nonce you can see 3, ABC value previous block from 198, and new hash is 105. Done? Has everybody got the answer? Now next, shall I share the next information, next block? Ready? Course number 4. Parks 320, student is different, E2, DD8A, grade is B. 213. Okay, 213. How many of you are approving it? 213. 213. Approving it? One team is approving. 2 team is approving. What else? 213. Approving. So 3 team. 2 and 3. Okay, so 4 team approved the 2 or 3. So that's your correct answer. 2 and 3. You can see the previous hash is 055. Then you have got this ABC 80, 69, 66. Random number you used 3. And then you got 213 which is divisible by 3. Shall I tell you show you the next block information? Or is there anybody who hasn't done? Group number 5. Have you done? Block 5. Do it. Engineering 300, E2, DD, 80. Somebody told me? One nine five. 195, 195. How many of you are saying 195? 195. Okay. Good one. 195. What is the last group? 7 number group. Are you doing it? Are you following me? If you are struggling somewhere, just let me know. I can repeat it. 195. 195. 69, 69, 68, 13. 195. Then last digit, last course. This is the block number 6 information. Engineering 300, BD, 7AF, grade is B. Tell me the hash. 107. 108. 108. 108. How many of you? 108. Okay, 3 groups. 108, 4 group. 108. Yeah, so that's the your final answer. 108. So tell me how it is how these blocks are interconnected, because we are using the hash from previous number. So this is just for the demonstration purpose. This is the your basically the for the simplicity purpose we use this hash. But if you look at the real hash, it is very lengthy. As I said, you can basically see the 16 times 18 times 0 in front of that hash, and then the additional information is available there. Suppose I am easily corruptible. So one of the student number 1, AD590A, that student want to bribe me to make that change from F to A. Can we do it? Now transaction is done, completely done. Now I want to make some changes here. As I said, I am easily corruptible. If you give me the 50 pounds, I can pass in that module. The student number 1. I can change from F to A. What will happen if I change that F to L, F to A? Everything will be changed. Let's see now. I will show you the Excel file. What will happen if you make that changes? So this is my course name. So I have given you only the 6 course, the student ID, the grade. This is a random number. This is a previous hash. Previous hash is our first hash is 212. Previous hash is 12ABC, and whether it is divisible by 3 or not. So everything is showing green, means that all the hash they are divisible by 3. Now as I said, I got the 50 pounds, 500 pounds from this student number 1. And I want to make the changes now. I want to convert this F to the A. Let's see what happens. So you can see that. Now what happened? Everything is affected here because of that. Nothing is working here. So this is the basic principle of blockchain. If you recorded all the information and then you try to make the change in the recorded information, all the hash, whatever the the code is there, blockchain blocks you have created, everything will be affected. Okay, so that's why we are saying that it is a transparent, secured information, and we cannot make any changes in those transactions. So if you want to see the exact, basically the blockchain information, just let me see. So this is one. So if I want to ask you, what course did C6745 take and what grade did they earn? Look at your table. Tell me. What courses did student number 67455 take and what grade did they earn? Business C67, student ID C67, business 200, and they obtained the grade C. So all the information is available to all the members. They can find that information. Student 2, what grades have they received? Student 2, they received the grade B. So those kind of information we can get from this your blockchain. Then what if we change the block 1? As I said, Parks 320, we changed from the AD from grade F to A. A grade is announced by someone other than a faculty member. Suppose, as I said, I am not aware, and if somebody announced that grade, student pays up a node, any node, to record an A for their grade. Student's private key is also lost sometimes. So again, whatever the key you have got, that is a private key. And if you lose that key, it will be difficult for you to find out the hash. A miner changes a transaction and announces that hash to the network before anyone else calculates it. The difficulty of calculating a hash increases as the blockchain grows. When your blockchain grows, the difficulty of finding that hash, it will be increases. So here let me show you the you can find out the this information about this game. So this is the website from where this is a J. Scott. He is a associate professor in Missouri University. So you can see now blockchain explorer. So if you want to see the exact hash and how it is developed, so you can see this is the bitcoin.com website, and you can see the the Bitcoin, and then you can see this is the, it is continuously updated. So this is a hash ID. Can you imagine how it is difficult? So I gave just one example of, but this hash ID is created using the previous information, the available information during that block, amount, fee, from which customer it is going, from where it is doing, hash is, so many important information is stored into this one. So this is just one example of how you can keep the records into the blockchain, and then how you can make it transparent, tamper proof and all those things. Then if you want to see some other latest transactions, let me see. So you can see average transaction time. These are the blocks continuously updating. Unconfirmed BTC transaction. Unconfirmed means they are not approved by the nodes. And this is a wallet. Then you can keep your Bitcoin there. And then let me show you the something else. This is a Etherscreen, again Ethereum blockchain, another platform. You can see the latest block here. Okay, so Ethereum price, miner, who is the miner that found out this block, and then you can see latest transaction. And when you click on this one, it is still loading. You get the hash ID. View all blocks, view all transaction. Sorry?
Sir, if you create a blockchain, and how many blocks depend on hash value?
Number of blocks, how
to depend? Number of blocks. How to validate this blockchain is good or not?
So good or not, it depends on the network that you are seeing. Suppose you are involved in the supply chain and you are only talking about supplier, manufacturer, distributor. Who are the parties involved in that supply chain? Accordingly, that. So yeah, this. So yeah, I gave you some table. I discussed one tables like first generation, second generation. Bitcoin is there, Ethereum is there. Some other platforms are there. So it depends on how much information you are getting, what you want to do, how much the energy you require, the computing power. Based on that, you decide. So basically, the basic the fundamental or logic behind the blockchain is this one that we discussed today. But again, as soon as you add the the information into the blocks, all those blocks are interconnected, and nobody can go back and change the transaction. Okay. So depends on the. I will explain the basically one case study as well. IBM's blockchain, how they use this blockchain to do the traceability of the food supply chain. So blockchain game is done. So blockchain applications in supply chains. So logistics and supply chain, tracking and tracing of the raw materials. So with the help of that hash ID, you can track and trace what is there in that hash ID, how much material you are getting, raw material, finished products from inception till it reaches to the end users. Significance, shipment tracking. You can very easily track the shipment. Transparent processes, all the members, they get the updates about this shipment. Dispute management. Why is it important? Why blockchain is important for dispute management? Because you have got the the records, and that is tamper proof. If somebody is not or taking the responsibility, or somebody is denying the accountability, we can very easily manage that dispute management with the help of this tool. Inventory monitoring and management and payments. These are some of the examples which blockchain you can use. Mux, SIP-chain, or AOG. Challenges: high implementation and operational cost. Not feasible for smaller organizations. So smaller organizations, they need the huge amount of investment. That's why sometimes the implementation of these blockchains are difficult. Healthcare and pharmaceuticals, securing health records, secure private storage and sharing of electronic health records. Sometimes in healthcare sector, you need the confidential information, and you want to transfer that confidential information securely with the other members. You can use the the blockchains. Like here, you can see genomics or mediculture. In tamper-proof data ensures traceability and non-repudiation for health records. Counterfeit medicine prevention. You can use this blockchain for the counterfeit medicine prevention as well. Okay, why? If suppose somebody is, we are making the digital record of each transaction. If somebody has done the transaction, and after that transaction, if somebody is trying to make the changes in that transaction, it is very difficult. You cannot do it. But during traditional way, during COVID-19, you might have heard that. What is that? What was that COVID vaccine? The medicine, remdesivir or something. It was that. So many fake medicines were there, and this kind of incidents you can avoid with the blockchain. Tracks and traces medicine in the supply chain. Another one very good example of how blockchain can be implemented in logistics. I told you the beef horse meat scandal in the UK. In 2013, the food authority in the UK, they did some random sampling of the sandwiches in a couple of grocery stores. So what they did found, in the expensive beef sandwiches, when they did the DNA testing, they found the DNA of the horse meat. Okay, and they did the proper investigation. So many the sandwiches were contaminated because of that one. When they started the investigation, what happened? The Tesco, all those major players, they said that we brought the basically sandwiches from one of our supplier. Okay, then when you go to that supplier that we used our third party to get that the chicken, beef from somebody else. So it was so complicated. The network, the members, they were from the UK, from the Europe and other parts of the world. So when they started investigating, everybody was saying that we didn't do this. We exactly send the products whatever customers want, whatever the retail was. We didn't put that the horse meat in the expensive beef products. But again, suppose you are exporting some food items from the India to UK. How do you make sure that the quality of that food is great, it's good, and you are saying that it is organic one? Okay, sometimes you say organic and non-organic. How do you make sure that the food that you are sending is the organic one? Because the people, retailer, those who are taking the food from you, so they don't come here. So normally some kind of certification, insurance you need to follow. You need to approve those the transaction, the certification body, the insurance body. They will do the check here, then they will approve that this is a really organic products. Then it goes to the other member, logistics provider. They pick up the products, they send to the other members of supply chain. So that traceability you can very easily do with the blockchain. Health supply chain counterfeit, drug detection, finance and insurance management, patient data, so many things. And these are some of the examples of this supply chain. And you can see basically what are the challenges in this area. Lack of standard data capturing and sharing procedures and mechanisms, data ownership and privacy issues. Food and agriculture, reducing the food wastage. How could you use the blockchain? So if you want to reduce the food wastages, you can get the up-to-date real-time information from the blockchain. What is the expiry date, from where it is coming, all those things, and you can avoid then food wastage. Improving food supply chain, tracking and tracing of food from farms to households. Okay, so nowadays with the help of blockchain you can track from who are your basically the farmers, from which farm that products you are getting. Significance, traceability of food supply chain, quality control, payments, logistics. Challenges: absence of standard rules and regulations. Again, we need some standard frameworks to run this blockchain. Lack of technical know-how, digital divide. Transportation logistics, tracking and tracing. So the IBM's blockchain, they the Mercs used to track and trace the containers they were transferring. Fuel monitoring, providing equitable opportunity for big and small transportation players. And significance, you can do the autonomous vehicle monitoring and management, road safety, payments. Again, the challenges: high implementation and operational cost, non-feasible for smaller organizations. Blockchain in supply chain. This is a very famous and classic case study of basically how Merck's collaborated with the IBM to track the shipments of their containers. Do you know the Merck's? This is a container shipping company. Background: Maersk, the world's largest container shipping company. The current contribution, the share is 18 to 20% of market share. They faced the challenges in tracking shipments and excessive paperwork in international trade. When you transfer those empty containers, or when you move from one port to another, from one port to another port, from one country to another port, there is a huge amount of paperwork involved in that one. Okay, because once that containers reach to the ports, the custom clearance is there, and if suppose you are moving the perishable goods, because of that time delay, your goods may be spoiled. So IBM proposed a blockchain-based solution. It's called Trade Lanes platform to streamline their logistics, basically the tracking shipments. What were the problems they faced during global shipping? Paperwork and overload. Each container required stamps and pay approvals from up to 30 people and 200 plus interactions. Imagine, just for one container, you need the permission approvals from the 30 people and then 200% interactions, and you are doing all these manually. You are going to those 30 people, you are taking the stamp, you are doing their signature, all those things. So it is unnecessarily increase your cost, time, all those things. So Musk wanted to streamline this process so that they can very easily move the goods from one port to another ports. Delays and inefficiencies: containers could be held at ports for days due to missing paperwork. One of the paper is missed, they cannot allow that container to the other network. Fraud and security: bill of lading. Again, they can tamper the bill of lading, were often tampered with the copy, leading to billions in maritime fraud. So these were the problems Musk was facing. So then they collaborated with the IBM to make that Trade Lanes platform. You can check, they have got the website as well, Trade Lanes platform, and you can see how they solve this problem. Key features of that Trade Lanes blockchain, which was built on Hyperledger Fabric platform: real-time tracking, GPS location, temperature, shipment condition. GPS tracking of each container, what is the temperature inside that container, what is the condition of shipment, everything they can track from their location. Immutable digital records, so basically prevents the tampering, forgery or fraud in those digital records. Instant document verification, custom authorities upload approvals digitally, reducing delays. Nowadays, because of this advancement technology, custom authorities, they can get the digital copies of all the paperwork with just in a fraction of minute. They can see all the information and they can approve it. So before you go to that, you take your the container to the customs, you can well in advance you can upload those documents, and the custom authorities, they will approve it. Increase the transparency. All stakeholders, Musk, customs, port authorities, logistics provider, they have access to this real-time shipment data. So they initially started the proof of concept. They did some test shipment flowers from Mombasa, Kenya to Rotterdam, Netherlands. The shipping cost was involved 2,000 USD. Paperwork cost was 300 during normal time, 15% of cargo value. The results was, they reduced the paperwork because of this blockchain. Handling time, ensured the secure document verification. Because as we have seen in this blockchain game, they cannot change the record of that digital transaction because it is linked with the previous your block. Okay, so they cannot make any changes in those digital records in those blocks. Increase the trust and transparency between trade partners. So this is the example of Maersk and IBM. Then they did the pilot project. This was the initial study, and then they did the pilot in 2017. They sent the Schneider Electric container from Lyon, France to New York, US via Rotterdam. Involved authorities. They involved the Netherlands Customs Administration, US Homeland Security and Customs, Maersk Supply Chain Company, Damco. Goals are track end-to-end shipment, test blockchain's efficiency in reducing custom clearance delays, and ensure the compliance with cross-border regulations. You can do the end-to-end tracking with the help of this blockchain. It reduces the custom clearance delays, time, and so on. Results: reduced the paperwork and processing delays, eliminated fraud risk with tamper-proof documents. So bill of lading during earlier cases, it was easily, it was the people were easily changing the bill of lading. So that's why, with the help of this blockchain, they couldn't do that, changes in the bill of lading. Improved supply chain visibility and efficiency. So all the members like customs, then the IBM, the Maersk, they got all the updated information about this supply chain visibility and efficiency. Enhanced the trust among global trade participants. Production launch planned by the end of 2017, and after that they expanded the trials to other products as well, pineapples and oranges from California. Any doubts in the IBM Maersk case study? The platform is available online. You can just search online. You can see what kind of blockchain they have built up. Another Provence case study. This is a startup company from the UK based blockchain startup. They wanted to do the track the basically the fish that the UK were buying, procuring from the Indonesia. You can see the link of that case study as well. Industry, fishing and seafood supply chain. So Indonesia is the major supplier for the the seafood. The project, they started pilot project in Indonesia 2016 to improve the traceability in the fishing industry. So they use some sensors, mobile phones, blockchain, smart tagging. These are the technologies they used for that traceability. Challenges they faced in earlier case fishing industry: lack of transparency. Seafood sourced from hundred of boats, making tracking difficulty. Suppose you are sourcing that seafood from hundred of boats. How do you make sure that which is a good quality seafood and from where you are sourcing that seafood? Similarly, suppose you are exporting some coconuts or grapes from the UK, from the India to the UK. How do you know that which is a good quality grapes, which is a bad quality? By the appearance, you cannot tell that. Suppose I want to find out organic and non-organic. How could I find out that? So that's why there is a lack of transparency, and we could use this blockchain to improve that transparency visibility. Quality control and sustainable claims are often unverifiable. Quality control means I could claim that my grapes, my products are very good in quality, they are organic, I haven't used any chemicals. Sustainability claims, we can say that my product is sustainable friendly, I haven't used any non-sustainable products, all those things. But who will verify that information? So that's why you need the blockchain. In the blockchain, some certification players are there, insurance players are there. They will check whether this product is really organic or not. Once that player will approve that only, then only the products will deliver to the next member. Fraud and overfishing. Illegal, unreported and unregulated fishing is widespread, because nowadays consumers, they are become very aware, and they want to know that how the suppliers, how the manufacturers made these products. So they want to check the environmental impact of their products as well. So fraud and overfishing, illegal, unreported, unregulated fishing is widespread in Indonesia. Counterfeit seed feed and mislabeling lead to consumer deception. Suppose your fish is not good quality and you are labeling it is a very good quality. how do the retailer sitting in the Western country, how do they know that whether it is a really good quality of seafood or not? Those kind of problems. Corruption and human rights issues. Again, bribery and fraud in the yellowfin tuna industry. Reports of forced labor and slavery in the Southwest Asian fisheries. So these were some of the challenges this the seafood industry experienced, and that's why they developed the blockchain with the help of mobile phones, sensors. How it worked? Tracked the fish from catch to consumer using mobile phones and smart tags. So when you apply the smart tag, it will tell you from where this the fish is sourced, how it is transferred from one node to another node. Immutable digital records ensure transparency and prevented fraud. So here you can find out the accountable people as well. If suppose I am the fisher, I source the fish from the sea, and then I got two kinds of fish, good quality and not a good quality, and I am claiming that not a good quality, it is still good quality. I am mentioning it, I am claiming it. Once that product reached to the retailer, and if they found that I am selling the non-quality, good, not a good quality fish as a good quality, they will blame me. They know that you are the person who is responsible to make that claim, and now you should be penalized for whatever the claims you are making. So that accountability you can get in these records. Smart contracts verified sustainability and claims and prevented data manipulation. Enhanced accountability for the fishing companies and authorities. So as I said, if some company is claiming that they are doing this sustainable business, their quality of the food is very good, how do we verify it? If something is not correct, then you can hold them accountable. Impact and results. Track the seafood supply chain for 6 months in Indonesia. Then what they did, first successful blockchain based seafood traceability system they developed. Increased the consumer trust by providing verifiable sourcing data. Consumer trust, suppose if I get the information of all the information of that seafood, from where it is sourced, how it is transported from the Indonesia to the UK or some other parts, who are the what was the temperature when they transport those things, how they sourced those seafood, and whether they used any child labor or any other things. So those kind of things will be available with the help of this blockchain, and that helps to increase the consumer trust. Potential to stop unethical practices including forced labor and overfishing. So when you declare that you are not following all the ethical practices, you need to make sure that as well you are not using any child labors or overfishing, all those things. Future potential application of this case blockchain. Largest tuna producing country, ideal for scaling blockchain solution. So you can extend this, scale up this blockchain solution to other the tuna producing country. Southeast Asia provides seafood for over 200 million people. Major industry impact, if everybody uses this kind of blockchain technology, so the whole transparency, visibility will be improved. 90% of the seafood in the US comes from the Southeast Asia, and now they want to check all the traceability of this supply chain, so they can do with the blockchain. Commercial launch could eliminate illegal fishing and unethical labor practices. So you can see here one example of how the workers, they are taking the pictures with their mobile phones, with the whatever the digital tags are there. Modem and pharmaceutical supply chain, another famous example of how we could use your blockchain to avoid the counterfeiting in the medical supply chain. So they wanted to ensure the safe delivery of pharmaceutical drugs by tracking the environmental condition. If you look at the COVID-19, you need that -70 to -80 degree temperature. How do you make sure that during the whole journey that temperature is maintained? So you can do that analysis with the help of blockchain. It will also tell you how much energy they consumed while maintaining that temperature. Challenges, medicines require specific temperature, humidity and light condition. Compliance with the European good distribution is very costly. Again, the Western countries, their compliance rules and regulations are very strict, and in order to deliver them, you need to follow them, and then that is very costly. Cold chain logistics are 4 to 8 times more expensive, leading to 3 billion in annual waste. Cold chain logistics, why it is expensive? Because of the requirement of the cold chain. You need the huge amount of energy to maintain that cold chain environment within your supply chain. So that is very expensive compared with your normal supply chain. So Modem's blockchain solution, what they did, they use the smart sensor track the shipments without costly refrigeration. Okay, so you don't need to invest into the huge costly refrigeration, or rather than you go with these sensors which helps to track the shipments. Data is stored on the Ethereum blockchain. The Ethereum blockchain second generation validated via Solidity smart contracts. If conditions deviate, conditions means the condition of that medical products. If it's deviate, automatic alerts notify sender and the recipient of that shipment. Pilot project they started in June 2016 to test the real-time monitoring and compliance automation. Walmart and food supply chain. Walmart used the blockchain for what purpose? To track the food from farm to fork. Objective was improve the food safety and traceability by tracking the pork in China and the produce in the US. Challenges, manual tracking took days to weeks to trace the food origins. If you start doing the manual tracking of all those products, pork and produce, so it takes huge amount of time and huge amount of cost. Okay, so what happens, guys, if there is some contamination happen in the food? How do you recall that one? Suppose in that horse meat scandal, when they found that, they did the recall of what? All the affected products. How do you know that out of whatever the products you sold, which are the affected products and which are not the affected products? How do you check that? You recall the whole batch. Okay. So, but in that batch as well, maybe some the products might be contaminated, some products might not be contaminated. Small, but again you are doing that whole the sample whole lot you are analyzing. So block. Yes. Good. In blockchain, you know that who supplied this product, contaminated product. Rather than recalling the whole lot, you can find out who made this lot, from where we got those lot. You can go to that respective corresponding entity and you can discuss with them. Okay, so here that is the benefit. Contaminated food recalls were slow and inefficient during the normal time, but blockchain, IBM powered blockchain tracks farm, batch number, storage, shipping, expiry date, everything. Nowadays, if you are taking the products from single farm, it will tell you that which farm they used to for this crop, which logistics provider was involved, storage, where they stored the product, shipping, expiry date, everything. Tracing time reduced from weeks to 2.2 seconds. Look at this one. From weeks, they reduce that tracing time to 2.2 seconds. This is very huge, development, I would say, because reducing the tracing time from weeks to 2.2 seconds, it is a significant achievement. They used other RFID tags, sensors, and barcodes for real-time data collection from the farms, logistics providers, and other members involved in the supply chain. Benefits: faster identification of contaminated food sources, preventing mass recalls. You don't need to, recall all the products. Have you heard the Volkswagen, the diesel scandal? Volkswagen company, the Germany company. Volkswagen emission scandal. Does anybody aware of that one? So Volkswagen, the Polo car. So what they did, they intentionally, in order to show the lower emission in the US market, what they did, they used some device in their car, and when they do the testing, that device will get activated and it will show the emission lower. When you done the testing, when you go onto the road, that device will get turned off, and then your emission will be different. So very interesting study. Volkswagen lost billions of USD during that case. It happened, I think, in 2005 or 6, and it was not like accident. intentionally the top team, top management, they intentionally did that one so that they can get the good sales in the US market, because the regulations were very strict in the US market for the lower emission. Okay, so that was the again case, because when they did the recall, all the Volkswagen model they made during that time, they recalled all the models and they made the changes in that one. They, in fact, they paid some compensation amount to all the customers who bought that car during that time as well. So sometimes what happens, you can use blockchain technologies to only recall the selected products, because we know that one of the members has done this activity intentionally. So you can, rather than recalling the whole lot, you can go with the selected products. Cost savings and improved customer trust in product authenticity. Walmart filed a blockchain patent in 2017 for package authentication and drone delivery. So some of the case studies you can see: Alibaba and Food Trust Framework. So what they did, they partnered with the Auspost, Blackmores and PwC to combat the food fraud, developing a blockchain-based food trust framework for supply chain integrity. Food fraud, food wastages, tracking, traceability, you can do with the blockchain. It ensures the traceability and authenticity for food products. Another example is the Lockheed Martin and supply chain security. They teamed up with the Guard Team Federal in 2017 to enhance the supply chain risk management. So if you want to manage the unexpected events, you can use this blockchain. Uses blockchain for secure, tamper-proof and data tracking, strengthens cyber security and compliance. Then another in pharmaceutical tracking, collaborated with the Link Lab to launch a blockchain track and trace pilot, supports the compliance with the Drug Supply Chain Security Act, and then enhances the drug authenticity and prevents the counterfeits in USD around 1.12 trillion industry. So what is the role of blockchain then in supply chain performance? If you look at the supply chain performance dimension, how we can use the blockchain to optimize your cost. In Maersk and IBM case, we used the blockchain to reduce the paperwork, to reduce the cost, to reduce the lead time. So it reduces the paperwork and administrative cost, enables the strategic removal of defective products instead of mass recalls. So during the recalls, you don't need to recall the whole lot. You can select the affected products and you do that strategic removal. It optimizes the resource allocation for shipping and logistics, lowers the regulatory compliance cost. Okay, because of this additional digital records, it helps to lowers your regulatory compliance cost. Mechanisms: IoT and blockchain for real-time tracking, digital records and smart contracts for process automation. So these are some of the impact of the blockchain on the cost side, how we could reduce the paperwork, administrative cost, and what kind of mechanisms we can use IoT. I think in our last session I told you that all these technologies, Industry 4.0 or Industry 5.0 technologies, they are integrated. Okay, you cannot use them in isolation. Like for blockchain, you need the IoT, you need some advanced connectivity technologies as well. IoT, Internet of Things, you need the blockchain to transfer that information, to track it. Speed, it digitizes the physical processes and interactions. So during the normal paperwork, it takes huge amount of time, speed to transfer that information. But because of this digital record, we can reduce the time there, reduces delays caused by the missing documents. For one container, you need more than 200 signs, paperwork from 30 people. If one of the documents is misplaced, your container will be held at that port. Enables real-time data sharing across stakeholders. Then mechanisms: IoT sensor for tracking temperature, humidity, movement. During that logistics, you can use the IoT sensors for the temperature tracking, humidity. Digital audit trials for fast verification, we could do that. Then dependability. What is the role of blockchain? It ensures the accurate measurement of product quality and authenticity. So suppose your suppliers are saying that these are the organic products, what is the quality? So blockchain helps you to certify that one. Okay, so whether they are the genuine products or not. It increases the accountability among supply chain partners. If one of the member is intentionally doing some wrong things for the financial benefits, you can find out who is the culprit in that network. You can hold people accountable. But during normal time, if you, as I said, in that horse meat scandal, after lot of investigations, after lot of the interviews and the trials, finally they found some one or two companies who did intentionally that contaminations for the the financial benefits. But here we can very easily identify it, who has done that change in that the network, who supplied that product. It could be your logistics provider, it could be your supplier, distributor, anyone. It provides a tamper-proof digital certification system. As I said, suppose your the certification body give you the certificate for the that organic product or whatever it may be. You cannot change that certificate. If logistics provider, they cannot change that digital record. So what are the mechanisms? Blockchain-based digital identity verification of the products, then smart contracts for automated approvals. Risk reduction prevents fraud by ensuring only authorized parties can access the data. So if confidential data is there, you can make sure that you are sharing that data with only the authorized parties, and you are not sharing with the other members. It provides a secure audit trail to track transaction and verify the authenticity. Again, you can do the traceability, tracking of the whole supply chain, starting from the supplier to the customer. It ensures the software file integrity and prevents the breaches as well. You cannot make any changes in the digital records. It secure blockchain authentication for transaction validation, tamper-proof digital ledger for supply chain transparency. Supply chain performance sustainability. How it helps to improve the sustainability? Increases the traceability to ensure ethical sourcing. Ethical sourcing is one of the important components for your social dimension. Okay, so you need to make sure that you are doing the ethical business, ethical sourcing. That helps to improve your social sustainability performance. It verifies sustainability claims for regulatory compliance. If one of the supply chain is saying that our products are very good, organic, you can check their these claims against the their products, and you can verify those sustainability claims for regulatory compliance. It enables the data-driven insights to improve the environmental impact. Mechanisms involved: IoT tracking for real-time supply chain monitoring, blockchain-based validation of sustainability metrics. Flexibility means supports different supply chain models across industries. So we discussed couple of case studies like IBM and Musk, food supply chain, Walmart, and another case studies related to seafood. So this blockchain, it supports the different supply chain models. It scales with the network growth to improve the efficiency. It enhances the consumer trust by providing the product origin details. Mechanisms: you can keep the digital records, blockchain-based traceability solution, mobile-based tracking and smart tagging. Then tell me some of the challenges now. We have seen the benefits, so many things. What are the challenges? Sorry? Initial cost is high. Okay. What else? Data storage could be problematic. What else? Yeah, that is also really important. Okay. Sorry? Yeah, that is also true, because you are using this to manage the huge amount of data. So consumption of energy is also very high. Anyone else would like to add anything in the challenges? Yeah. So legal and regulatory complexity, navigating diverse laws and regulation across jurisdictions. So you are doing the global supply chain, global supply chain and logistics, and you are using this blockchain. So obviously you need to follow the rules and regulations of the different countries. Okay, you sometimes getting those certification, getting the approval is very difficult. So you need to follow those one legal and regulatory frameworks. So this is one of the challenges. Collaboration issues. Difficult to align parties. Our ledger took 18 months to establish. Collaboration. Suppose you are the main player in your supply chain and you are trying to implement this one. Other small players, how could they get benefits of this one? They might think that you are trying to collect some confidential information from us. So that collaborations will be problematic because of the this is a really new technology, and you are trying to capture the the real-time information from those members. Physical virtual gap. Blockchain can't detect physical changes. This is really important. This is one of the challenge. We are all talking about the digital records. If somebody tampers the digital record, then only you can detect it. But what happens? Suppose somebody tampered the physical object. That tag is correct, but they changed the object. Suppose fish is there, whatever it may be. They changed that fish. Tag is showing that it is an authentic one. But what happened when there is a contamination in the physical changes? Blockchain can't detect the physical changes. Centralization risk, corporate blockchains like IBM's limit access, increasing vulnerability. Technological barriers, developing countries struggle with the blockchain adoption limiting. So developed country, they have tried to implement this blockchain, but again only few companies they have implemented. But if you look at the developing countries, very few companies they have started implementing this one because of the huge amount of investment and lack of frameworks, regulatory complexities. So that is a technological barriers. Energy consumption, somebody say that, yeah, high energy use because of the huge amount of data that contributes to the CO2 emissions. Security and privacy, frequent breaches, cyber attacks and privacy risks if you don't manage your blockchain properly. Adoption and integration, slow adoption, integration issues with legacy systems. Companies, they are slowly adopting these technologies because this technology needs some other integrated technology, IoT, your artificial intelligence, sometimes your the cyber physics, cloud computing and so on. So that's why slow adoption. Cost and efficiency, high setup cost and low transaction efficiency. And this is the last slide, information transparency. Sometimes we say the information should be shared with the other one. So what are the business case? Opaque, translucent and transparent information. Opaque means for any variety of reasons, no information is shared between the parties, even operational data. Opaque means no information sharing. Translucent means outline information only shared, interface condition or partial. So part of information is shared. Transparent means information is shared on a selective and justified basis.
How blockchain has no efficiency? We saw that the efficiency was reduced from 2 weeks to 2 seconds.
Mm-hmm.
So it's more efficient.
Which one we are saying? High setup cost and low transaction efficiency. Yes, correct. High setup cost, but transaction efficiency is faster compared with your traditional databases. Yeah. So there is, the problem with that last one. Good observation. Thank you. Okay. And this is the end of our today's session. Now, if you have any doubts, any question, I will be uploading the slides, all the game, so Excel files of this blockchain game. Very interesting website, guys. This one, blockchain. You can go to this blockchain and you can see what they have done. All the slides are there. You can see how they are playing that game. Everything is there. Any doubts, any questions? I hope you have understood something about blockchain today. Okay, something how it basically works. What is hash or all those things. So if you say this kind of where is it? So if you see this kind of hashes here, now you try to at least check what is the meaning of that hash, how it is generated. Ethereum, again another blockchain platform is there. You can see here transaction hash, block is there, age, from, to, amount and transaction fee. Anything? Any doubts, any questions? So I have given all the references as well for all the slides. So you can check that references here as well. Okay. So everything I have given. Very interesting papers are there. Because you need to manage that huge amount of data, computing power. Suppose you have got the complex automotive supply chain, 1,000 suppliers are there, 1,000 distributors are there. So each distributor we have got one node. Okay, so 1,000 distributors, 1,000 nodes are there. When some new block is added, all those thousands of suppliers nodes, they need to approve it. 1,000 nodes means you have got thousands of computers. Okay, so that's why it becomes very complicated. Let me show you very interesting one video, then you would understand it basically. See, Infosys blockchain, very easy to understand. We already talked about this one, but little bit.
Hello, 199.
A typical agricultural supply chain involves complex interconnected processes between various stakeholders such as the producer, inspection and insurance companies, logistics and shipping agencies, banks, manufacturer and importer before it reaches a consumer sitting in another corner of the globe.
These are the members of your
However,
supply.
in this long process, there are quite a few challenges. Importers find it difficult to track provenance to understand the place of origin and quality of the imported produce. As the produce moves between multiple stakeholders, the ownership or custodian information becomes difficult to trace. Centralized bodies, especially private agencies that certify crop produce, may not be trusted by international importers. Information flow between stakeholders is sequential, leading to potential delays in downstream decision-making. Overall, stakeholders lack transparency in this process and lose track of relevant transactions. So, how do we tackle these challenges? Introducing Infosys Blockchain. Any activity can be documented and stored in the distributed ledger only with consensus among all participating stakeholders, thus making the network more trustworthy than any individual entity. Untrusted stakeholders can transact amongst each other through smart contracts without the need for a stakeholder with information access in near real time. Short from Uttar Pradesh, information access in near real time. Meet
given
Raj
some one
Kishore
example.
from Uttar Pradesh, who specializes in mango cultivation. Every year, Raj sells a bulk of his mango produce to Mohan, who owns the Royal Pulp Factory in Uttar Pradesh. Mohan, in turn, receives an order to export mango pulp to Charles Becker, who owns Becker Packaged Foods in Germany. He will add details about his crops, request
the details of
inspections,
the records.
and get his produce in short at the right time. The contracts between Raj and Mohan, as
this is
well
a
as
smart
between
contract
Mohan
between
and
the-
Charles, are stored on the
Mohan and
blockchain
then
network
Raj.
as smart contracts. Relevant stakeholders certify the produce with standard certificates. Once the mangoes are harvested, Raj
You can see here contract between Raj and Mohan, contract between Mohan and Charles. Insurance papers are there for this Raj. Inspection certificates to make sure that your products are good quality.
generates the invoice and requests a pickup. The logistics company picks these mangoes up from Raj's farm and delivers it to Mohan's warehouse. The delivery receipt is updated and made available to all stakeholders on the network. Once Mohan accepts the consignment, the smart contract between Mohan and Raj is executed, and Mohan's bank will be notified to initiate an open account transfer to Raj Kishore's bank. The transaction details will then be updated on the blockchain network. Meanwhile, Mohan is busy making mango pulp to be delivered to Charles Becker. The pulp is inspected and certified as well. Mohan then issues an invoice to Charles. Charles tracks the provenance of the product entirely from where the mangoes were cultivated to the inspection and insurance details before accepting the invoice. Mohan then raises a shipment request with the shipping company. Once the bill of lading is uploaded by the shipping company, the smart contract between Mohan and Charles gets executed, and Charles's bank initiates a payment to Mohan's bank. Transaction details are updated on the network. Thus, Charles, sitting in Germany, is able to remotely track the provenance of the mango pulp imported from India. Emphasis blockchain.
That's the example of how the blockchain works. The members, those who are sitting in the Western countries, they can, with the help of this smart contracts, insurance certificates, they are they can see the quality of that product, then they will see the certification, and then they will approve it. So that's just one example. You can go to then IBM's trade lanes digital blockchain. You can see how it works and all those things. There are so many applications of this blockchain in different areas. So then you could basically analyze those things. You could use it for research purpose as well. Those technologies, how we could make it more efficient. The investment cost is there. How we could reduce that investment cost and all those things. And if you get the time, read that first paper as well. The first paper published in 2008. It is very interesting. Okay, I hope you had enjoyed this today's session, and I will see you tomorrow for last session. I will share these Excel files as well. You can see the worksheet, grades, random. It is available on their website as well. Lookups, function, private key, then public key. Tomorrow, Venkat, I think it will be again 3 to 5. So I will ask that Chinmay to send the timing. 3 to 5. The trends in next generation supply chain.